Hi, this is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about the topic attenuation, absorption loss, scattering loss, and bending loss. This topic comes under the unit number 4, optical communication. As we are discussing about the optical and fiber communication in this playlist, we are going to have the discussion about the attenuation and absorption loss, etc. in this session. Come, let's get into the topic. First, before getting into the topic, actually, what is actually attenuation? So, attenuation is nothing but of simply in the term, it is reduction in the power. That is a signal strength of optical signal as it travels through the optical fiber. So, it is one of the key parameter affecting the performance and efficiency of optical fiber communication systems. Attenuation limits the maximum distance the data can travel without the need for amplification or regradation. So you can see the image. That means here in x-axis it shows the wavelength and y-axis attenuation. Attenuation the unit of decibel per kilometer. So in each and every wavelength of the visible light, we have that is set of optical windows where how the attenuation is affecting in each stage is depicted over here. So this is the image. And for the definition of attenuation, the optical fiber communication is the gradual loss in the signal intensity measured in decibels, that is dB, as the light pulse travel down the fiber. It is expressed in decibels per kilometer, dB per kilometer. So you can see the image where the input power, which is specified as Pi, and output power represented as a Po. That is input power, output power. So when it is traveled down to the optical fiber, it experiences the attenuation when the distance increases. So that is the thing which this image represents. And what are the causes of attenuation? There are several causes. First thing, absorption losses. That is, there are two absorption losses here. That is intrinsic absorption loss and extrinsic absorption loss. So intrinsic absorption loss, which is nothing but of it is caused by the basic materials of the fiber. That is a silica. It dominates at wavelengths below 800 nanometer and above 1600 nanometer. And extrinsic absorption, that is nothing but of due to impurities like transition metal ions or water present in the fiber. So oxygen ions absorb light strongly around 950 nanometer and 1240 nanometer and 1380 nanometer. And the next cause is scattering loss. So scattering occurs when the light interacts with small variation in the material density or composition. So there are two things. One is a ray light scattering and one is a MIE scattering. And next one is bending loss. So by the name itself, we can understand what is actually a bending loss. So when you are bend the fiber, that experiences the signal light. So light will be experiences some losses. So that can be classified into two types. One is a macro bending, another one is a micro bending. So macro bending is nothing but of a large scale bending, and micro bending is nothing but of a small scale bending. And let's have the classroom activity. So I have projected two images. That is a rebus puzzle, where we know what is rebus puzzle. Rebus puzzle is a combination of symbols, letters, and some images. So from the collection of these things, you have to find out the some logical answer hidden in this puzzle. So you just discuss with your group members and find out the answer for each grid in this rebus puzzle. So let us see which team which cracks this rebus puzzle. So the answer for rebus puzzle is projected over here. So this is the answer. So let's resume the session. Then the attenuation coefficients. So what we discussed in the previous slides are what is attenuation and what are the causes of attenuation. Here the formula for attenuation is represented here. That is nothing but of alpha, which is equal to 10 by L log base 10 P in by P out, where P in is the number of input power and P out is the output power, where L is the length of the fiber and alpha is the attenuation in dB per kilometer. And typical values for attenuation is modern single fiber have attenuation value of low, that is 0.2 dB per kilometer at 1550 nanometer, and at 1310 nanometer attenuation is around 0.35 decibel per kilometer, and 850 nanometer it is used in multimode fiber attenuation is higher, typical around 2.5 dB per kilometer. These are all some typical values of attenuation in the optical fiber communication. And how to increase, how to effectively, change the communication, effective communication. That means high attenuation reduces the distance over the data which travel without regeneration. To mitigate this, optical fiber we can use, optical amplifier we can use, and repeater we can use, and wavelength selection. So selecting the appropriate wavelength for our application, which increases the effect of the communication. And how to minimize the attenuation. So to minimize the attenuation, we cannot completely overcome the attenuation. We can somehow we can minimize. So these are all the some minimization technique where we can improve our fiber optic communication. One is using high purity glass in fiber manufacturing. Another one is a controlling environmental factor. For example, there is a moisture, and avoiding tight bends and mechanical stress. And the next thing, proper fiber splicing and connector practices. Let's have the assessment. So there are 5 questions I have mentioned over here. Just take the assessment and send to me, send to the your Google Forms, which I already shared in the WhatsApp group. Thank you.